Okay. Question 5. Major highways incorporate ramps at the side of the road. This is to prevent people crashing if they've got faulty brakes. Smooth ramp gradually rises to a horizontal gravel track 40 metres above road level, as shown in the diagram. Okay, so we've got a gravel track, we've got a height of 40, got a mass of 5,750, got a speed in metres per second, kilometres per hour. Convert the speed of the truck from kilometres per hour to metres per second. Well, we know that 1 kilometre per hour is equal to 1,000 metres per 3,600 seconds. So to go from kilometres per hour to metres per second, you divide by 3.6, and to go back the other way, you times by 3.6. So straightforward this one. 140 divided by 3.6 is equal to 38.9 metres per second. Right, determine the kinetic energy of the truck at the road level as it approaches the ramp. Okay, so down here, what's its kinetic energy? EK equals a half mv squared, which is equal to a half by the mass, which is 5,750 times by 38.9 squared, and that gives us 4.35 by 10 to the power of 6 joules. You can't see my decimal point in there. So 4.35 by 10 to the power of 6. What is the kinetic energy of the truck at the top of the 40-metre height ramp just prior to entering the gravel track? Okay, so we had the EK before at ground level at 4.35 by 10 to the 6 joules, but it's now going to rise up a height. So EP, gravitational potential, is mg delta H. So that's going to be 5,750, because that's the mass, times by 9.8, times by 40, because it's 40-metre rise. So some of that kinetic energy is going to be converted to potential, gravitational potential, which is 2.254 by 10 to the power of 6. So what's the kinetic energy? So EK at the top is going to be the kinetic energy it had before, which is 4.35 by 10 to the power of 6 minus 2.254 by 10 to the power of 6, and that's going to give us 2.09 by 10 to the power of 6 joules. 2.09 by 10 to the 6. The gravel track then exerts an average frictional force of 25,000 newtons, so F equals 25 by 10 to the power of 3 newtons. On the still moving truck, determine the distance the truck continues to travel until it fully stops. Okay, well, we know that change in EK is equal to work done, which is equal to force by distance. So the change in EK from previously, when it got up to the top, it had 2.09 by 10 to the power of 6 joules of kinetic energy. So that's all going to be converted back to force to stop, or sorry, the work done to stop it. So the force is 25 by 10 to the power of 3 times by D. So divide both sides by 25 by 10 to the power of 3, and that gives you distance travelled 83.8 metres.